Dawn is one I call it's sort of the little engine that could.
The spacecraft was launched in 2007, and for 14 months in 2011 and 2012, it explored Vesta, the second most massive asteroid in the main asteroid belt between Mars and Jupiter. And now it's on its way to become the first spacecraft to visit a dwarf planet, Ceres, in 2015. This is the first spacecraft ever to orbit an object in the main asteroid belt, and it's the first spacecraft in more than 56 years of space exploration to plan to orbit any two solar system destinations. And a mission like this would be completely impossible without ion propulsion.
Ion propulsion uses electricity to propel the spacecraft. We take xenon gas, ionize it, and accelerate it out the back of the spacecraft. The thrust you get out of the ion propulsion system is about as much as a piece of paper pushing down on your hand. For instance, an analogy is a car goes from 0 to 60 in about 4 seconds. We go from 0 to 60 in about 4 days. But we keep our foot on the accelerator and we keep thrusting for days and weeks and months and achieve much higher velocities than a traditional rocket.
Well, Vesta had been observed by astronomers for more than 2 centuries, but most of that time it was little more than a fuzzy blob of light amidst the stars. So it beckoned, but its invitation wasn't answered until Dawn arrived in 2011. And then it revealed this whole fascinating, complex alien world with precipitous cliffs and towering mountains, vast craters punched into the crust, a whole fascinating world that really is more closely related to the terrestrial planets than it is to what people think of normally as asteroids. One of the things that I think is so interesting about Dawn is the way it got into orbit around Vesta. With its gentle, whisper-like thrust, the spacecraft just crept up to Vesta and let Vesta's gravity gently take hold, and the spacecraft then was in orbit. And it spent 14 months there, taking advantage of its ion propulsion system to maneuver extensively to optimize its scientific investigations. And then it gradually spiraled higher and higher and higher until it just gently, elegantly departed and then was on its way to Ceres, entirely unlike the way conventional missions do it.
All future manned missions to Mars or places like that will take advantage of the fact that this little putt is much more efficient in terms of moving mass from one place to another than the rockets with all their dynamic explosions.
Any mission that requires extensive maneuvering in space really is a candidate for being done with ion propulsion. It really provides a tremendous capability. In fact, even now in early 2014, Dawn has changed its velocity by nearly 21,000 miles per hour. And this has all been done just by this one spacecraft with its own propulsion system. So it's really remarkably capable.
We've got a fantastic team, both at the Jet Propulsion Lab at UCLA and partners around the country and around the world that are working on this mission. A lot of time and effort and years and tears have gone into this mission to make it the success that it is.
For the future, I think this opens up really many possibilities for exploring the solar system that would not otherwise be available. And as for what lies ahead, I think Ceres is going to be every bit as fascinating as Vesta is. And I think it's really going to be exciting to see what discoveries Dawn can make there.